Hey folks, welcome back. This is going to be an interesting one. If you don't know, I am all in on ExpressLRS. It's the one protocol that can control everything from my whoop to my X-Class and everything in between, even fixed wing. It's not locked down by any one manufacturer. Anybody can make it. Heck, even you can make it. And I can make it. All the plans are out there. It's all open source. Awesome community, great developers, and just a really, really good product. ExpressLRS wouldn't have all the hype if it just was a mediocre protocol, but it's kicking the pants out of just about everybody in just about every case. But manufacturers are listening to people. They want ExpressLRS inside of the radios, like the Jumper T Pro, or like this one here, the Radio Master Zorro. But not everybody wants this radio, or wants the T Pro, or the upcoming Commando 8 if it's not already out. Many people already have radios that they really like, and they like the form factor, and they're already paid for, so they want ExpressLRS inside of the radio, like this one. This is the Frsky Xlite Pro. It's an access radio. It does access. It does D16, FCC, and LBT. It does ACCST 1.0, 2.0, access 1.0, 2.0, all that stuff. It has an external module bay. All right, so we can go and slap an external module on there if we want to do that, and then we can have ExpressLRS, but that's not what we want. We want ExpressLRS inside our stuff. What if I told you that this radio has all the functions that it had when it came from the factory, from Frsky, has access, has external module bay, and it has ExpressLRS inside of it with no visible modifications whatsoever. And on top of that, it also has VTX backpack. Yeah, Jumper, you forgot that, didn't you? Yeah. Well, I got it. I got it all inside of this radio, and it's all in a form factor that's roughly this big. And this doesn't just apply to the Xlite. This applies to just about any radio out there that runs OpenTX, EdgeTX, something like that. If I piqued your interest, stick around. This might be a long one, but you may want to watch this. It may answer a lot of your questions about ExpressLRS, or how it works, or how the configurator works, or why is this open source, or how is this open source. Let's head over to the bench, and I'll show you what I got. So, first and foremost, obviously, we need a radio. We need a radio that we're going to modify. We're going to modify this here, Xlite Pro. It could be any OpenTX-enabled radio. Doesn't really matter. This will work for all of them. At least I think it will. I haven't tried it on all of them, but they're all basically the same. You're going to need a LoRa E28 module. This is the heart and soul of ExpressLRS. This has the transmitter, has the amplifier, and that's where we hook up our antenna. I need one of those. You're going to need ESP32. This is the brains of the operation. This is what controls everything. It has a Wi-Fi antenna because it has Wi-Fi. We're going to need this. This is a little DC to DC converter. We're going to need this to power the whole mess. We're going to need an antenna. This is the first time the HappyModel antennas are actually be worth a damn. They're nice and flexible. It's going to work really great in our modification here. We need one of these. This is a 10 microfarad capacitor. We're going to need one of them. We're going to need one of these little guys. This is a 10 kilo ohm resistor. We're going to need that. It's very easy to lose. Luckily, when you buy them, they're dirt cheap, and you can get a ton of them. If you want the VTX backpack function, which I highly recommend you do, unless all you fly is DJI, then you don't have to worry about this. But if you're flying analog or you're flying Sharkbite, you're going to want to pick up an EP82 backpack from HappyModel. You're going to want to pick up 2 of these if you're flying any module other than the TBS Fusion. If you have the TBS Fusion, just buy one. The TBS Fusion has all the hardware in it that makes it so you don't need a second one of these. And you're going to need a PCB. This is one of my designed PCBs. There is an ExpressLRS project that has a tiny PCB like this, but it is too big. I needed to go smaller, and to get this small, I had to sacrifice the silk screen. So, silk screen's not very good on it. It's also my first PCB design, and it works. So, you'll need that. You're gonna need an FTDI adapter like this one here, and some wires to connect it to all this stuff. Other random things you're gonna need, just random wire, capped on tape, old broken prop, vise, soldering iron, solder, solder wick just in case you have a oops, and the absolute most important part of building anything, one of these. This is a 10 times jeweler's loop with a little LED in it. This can make or break just about any project that you're working on. Resistance checks, continuity checks, all that stuff, that's fine. Visual check, far more useful in my opinion, and far easier to do. So like I said, you're going to need the PCB that I have here. It is the smallest PCB that I think I could make for all the components you need. It offloads the voltage regulator to a separate location. It allows you to put the VTX backpack in a separate location so they're not tied to the same board, because this Xlite, this has got to be the most compact radio on the market right now. There's almost no space in there without actually making any physical modifications to the radio. So we can see here, this is Easy ADA, Easy EDA, whatever. This is where I went to design the layout for the board. Here we have our schematic. I'm going to leave links to all this stuff, all the parts you need to buy, all that stuff. And you know, I'll even put these PCBs for sale on my website. I have a whole stack of them. I'm not going to need them, so I'll sell them there for, I don't know, a couple bucks, whatever. I'll put all the links to everything in the video description. Maybe put this on GitHub if somebody can show me how to do GitHub. I don't know. GitHub confounds me. I don't know. We'll see. Anyways, here is the schematic for our PCB. We have our ESP32. We have our E28 LoRa module. We have input from the radio, so it only uses 3 connections: power, ground, and S port. This is a connection to the UART, so we can flash the ESP32, and also in the end it will be how we communicate with the VTX backpack. We'll put this out there right now that once this thing's all installed, you're going to have only one way to flash this stuff, and it's going to be over Wi-Fi. Hopefully your ExpressLRS and Wi-Fi game are strong and you know what you're doing. By the end of this video, I hope you'll understand how it all works. But remember, this is not I just bought my first quad, I'm going to do this type of project. You need to be in this for a little bit. Because we're going to be doing some stuff today. Here's what the PCB looks like when we're looking at it connection-wise. And again, I'll leave links to all this stuff here. So it's nice and easy. I don't have the silk screen on the PCBs, but if you hover over these things, you can figure out what is what. So we've got ground, VBAT, S port. You can see where it goes on the ESP32. And we can also look at the bottom layer here. This is the backside where we have the LoRa module and all the connections back there. And a nice little 3D rendering. This is the ESP32. This is our UART pad, our power in, power out to the regulator and back in. So this is, you know, the radio power in and signal. This is VBAT out to the regulator and then back in from the regulator. And on the back here, we have our spot for our resistor and our capacitor. You notice here, it's a nice little line right there. Yeah, that helps. You're gonna need to pay attention to that. All right. So in the end, it's only a few connections to the ESP32. It's only a few connections to the ESP32. It's only a few to the LoRa module, but you're gonna want to solder all the legs. This is some very tedious, small soldering spots. It's very easy to screw this up, but if you're willing to tackle this project, I'm pretty confident you're gonna be able to do it. Plus, all this stuff is dirt cheap. The LoRa module is probably the most expensive part. And I'll show you a trick for not wasting the LoRa module. All right, with all that said, let's head over to the bench and let's get started. So you're gonna need to get yourself a vise. This is just a 3D printed vise that I found on Thingiverse. I like to use it. This is what I'll be using. If you're looking for this STLs, look for yet another vise. All right, here we go. Get our iron. I heat this sucker up. First thing we're going to do is we're going to solder on our resistor, just because that's the thing I'm going to lose the quickest. The orientation of the resistor does not matter. It's the first thing I'm going to lose, and I don't like fighting myself and working backwards, so we're going to put that on there first. So I'm at, what, 850? Yeah, that should be about right. I like this tip. One side, and there's the, that's out of frame. There we go, and there's the other. So we got a resistor in place. All right, that's about as close as I'm gonna be able to get you guys. And still give you a clear image. Next, we're gonna solder up the capacitor. Remember that 3D image I showed you? How there was a line on the capacitor? Here's the capacitor, and this is that line that I was talking about. That needs to go towards the resistor. Got our resistor and our capacitor installed. That's not the prettiest job. I've done better, but this isn't a very good platform for me to be doing this on. But it is what it is. All right, let's flip it over. Let's get this ESP32 soldered up. Now, normally when I do this, I burn the chip in first on one of these burn-in boards. It just makes my life a little bit easier, but if you guys are doing this, this is probably how you're gonna be doing it. You're gonna flashing it with a FTDI, so we'll do it the way you do it. All right, so drop that guy in place. Try to center it up as best you can on all these pads. We're just gonna solder in one pad for now, and then we're gonna kind of nudge it around to get it to where we want it. Just gonna go ahead and center it all up and kind of bridge that solder between the module and the board. All right, so it's held in there just a little bit, just by that one little corner right there. And we're just gonna check to make sure it's lined up as best we can get it. Go ahead and hit a few more pads just to kind of tack it into place. The ground pads are always gonna be the hardest to solder just because there's a lot of thermal mass behind them. All right, that's tacked in place, it's not going anywhere. Just gonna go around and hit them all. Okay, so I do have a few bridge pads, which I about guarantee you're going to, unless you're like really good at this, and if you are, you're probably not watching this video. A couple different ways to get rid of that. Clean your iron off really good and just kind of swipe up between them, or you can hit them with some solder, some desoldering wick. It's kind of up to you. I think I can get away with just getting the iron hot and swiping up between them. Take your jeweler's loop, take your board, take a really good peek at it. Make sure you don't have any contacts that are missing solder, and you make sure you don't have any that are bridged. Got one that looks a little cold. You get a little kind of a crinkly look to it. It's usually a cold joint. You can just hit that little more heat. There we go. That should look good. That is what your joint should look like. Okay. All right, now before we go any further, we're gonna wanna solder up our FTDI adapter to the board so we can flash our ESP32. make sure this thing's working before we solder up our LoRa chip, because that is the most expensive part of this entire build. So let's not waste that. So looking at the board here, we're gonna have ground, power, RX, TX, and boot. We're gonna need to hook up to all of these. Remember, when you hook up your FTDI, TX to RX, RX to TX. Okay, now when we hook this up to our FTDI adapter, be very careful. Make sure that we're using ground 3.3 volts. And then RX is going to go to TX. And TX is going to go to RX. All right, now when you go to connect your FTDI to your computer, which is using this extension cord here, you're going to want to make sure we ground out that boot wire. That's this random loose wire we have floating around back here. Just go ahead and touch the side of the can with it. Doesn't really matter. And plug in your FTDI. Come back to your PC, open up the ExpressLRS configurator. If you don't have it downloaded already, just search for it. This is an advanced tutorial. I'm not telling you how to install the ExpressLRS configurator. We're gonna go to DIY 2.4. We're gonna do DIY 2.4 TX ESP32 SX 1280E28. Put all your pertinent infos in and come down here. I'm gonna do COM10 and hit build and flash. Make sure you have TX backpack enabled. And this will take a few minutes. And we can see it's writing. It's the first good sign. All right, so we have the word success. That means we succeeded at flashing the module. Congratulations. That's the first hard step. All right, we can disconnect our FTDI. And we can desolder all of this mess. We're not going to need it anymore. As long as we don't screw up, we're not going to need this anymore. All right, we can take this guy, we can put that aside. Let's focus our attention on this. This is our DC to DC converter. We need to make this thing run at a very particular voltage. And the way we're going to do that is we're going to take this trim pot here, and we're going to turn it all the way clockwise as far as we can. You should just do this with my fingernails. There you go. You just turn it as far as you can, clockwise. All right, now we're gonna go to the back of it. And we need to bridge two of these connections. We need to bridge the 12 volt and the 5 volt. All right, this is one of the harder things. I don't know why it's so darn difficult, but we need to bridge the 12 volt pad here and the 5 volt pad. Good luck, Godspeed. You'll figure it out. There we go. 5 volt pad down here and the 12 volt pad up there are now bridged. As always, go ahead and double check your work. Now we're going to focus on this side of the board. We're going to hook up our voltage regulator. And the way this is going to work, this is going to be 3.3 volts. This is going to be 3.3 volts out from the voltage regulator. So that's going to be VO plus, and then ground, and then VBAT, which is going to be VBAT out from here into here, which is going to go to VIN. So it's going to be basically like as if these two were joined like that. All right, but we're going to put wire on them so we can mount these remotely. How much wire? Good question. I don't know. However much you want to use. You can always trim it up in the end. Or we can tuck it all away, one or the other. All right, so. All right, so we have 3.3 volts into this board. We have ground out of this board, and we have VBAT, which is basically our radio voltage, coming out of this board into our regulator. And then out of our regulator is going to be our 3.3 volts. whatever it is into that board. Now, here's the step I like to do. You can actually hook this up to your radio as it is right now, run the ExpressLRS Lua script, and see if you can communicate with the ESP32. If you can, good, we can press on. If not, we screwed something up and we need to start over, or we need to figure out where the error is. Most likely, I'm assuming if you're doing this, you don't have another radio to use to troubleshoot. I do, and I'm going to show you how to do that. I like to just use a 3-pin connector like this. You can use whatever connector you want. You can use the pins for the back of the module bay if you want to use that. It's entirely up to you. I'm just going to do it the way I do it. VBAT, ground, and S port. Connect it to the back of a JR bay. It is S port, ground, and power. Make sure nothing's touching anything. Power this up. Make sure your external module is powered on, like through the model. Just gonna go to Systems, we're gonna go to ExpressLRS, and there. We have communication with the ESP32. We're good to go. We can press on from here, and we're not gonna have to worry about desoldering our ESP32 and all our boards. Now that we know that our board has communication, you can skip the step if you want, if you're confident. It's just an error trap for me. That way I don't have to worry about trying to salvage the LoRa module off the board. And at least I know up to this point, everything works. So we can just keep going. And I'll put a pin out for the JR bay and the TinyELRS bay on the screen here. So if you want to try doing it, you can do it yourself. Okay, next thing we have to do is we have to solder our E28 chip to our board. This is a lot like soldering the ESP32. It's honestly just a little bit easier. If these wires are in your way, feel free to disconnect them and go back and reconnect them afterwards. And just like before, we're gonna just try to tack it in place. All right, it's in place. It's pretty well centered. Just continue out, soldering the rest of it. All right, just like before, I have a few bridge connections. Just swipe up, try to get rid of them. All right, all our pads are no longer bridged. Now on to the absolute hardest part of this entire job, and it is activating the UFL connection. So as it sits right now, there is a 0 ohm resistor. Yes, 0 ohms means it's just a short right here. We need to remove that bad boy, and we need to bridge this connection here with the center here. A lot of people just move this resistor. That's completely pointless. You don't need to do that. You do need to remove it. So we'll get her out of there. A little solder on your iron and just kind of push that guy out of the way. There we go. That's gone. Now we just need to bridge these two connections. Try really, really, really hard not to touch your UFL with your soldering iron because you get solder on it and it becomes very difficult to connect an antenna to it. All right, if you find yourself struggling with this, the easiest way I know of to make this happen, just take a little bit of wire and tin it up. Just lay it across those two pads and hit it with your soldering iron. And then just snip off the excess. Be very careful you don't damage the substrate. Yeah, and then just check your work. You can see we've got our wire bridged between these two pads here. This one is left alone. We do have a little solder on the side of the can here, and then we have a little bit on the edge of the UFL. Shouldn't be a big deal. It's not a ton. I think we can work through that. If you want to, you can always grab your soldering braid and very gently try to remove the excess. May cause more problems than it's worth. There we go. So from this point forward, do not power this up without an antenna connected. Before, it would have just transmitted through this little PCB-based antenna and you would have been fine. Now it's going to try shooting all the angry pixies out of this port here. Don't do it. Okay, so at this point, if you don't want to do the VTX backpack function with this little guy here, you don't have to. You're done. You can just move forward to slapping this in the radio. The whole point of this is to have a full-featured ExpressLRS experience. So we're going to now connect up this little guy to the board. But before that, we need to flash it. If you look on the board here, it has a really nice silk screen. We have ground 5 volts, TX0 and RX0, that's UART. So what we're going to do is we're going to hook our FTDI up to just ground and 5 volts. This will work on 3.3 volts. Just because it says 5, it would prefer 5. Works just fine on 3.3. We don't need RX and TX. You can use them if you want. You don't need it. We can do this over Wi-Fi, or we can do it through the FTDI, and we'll hook up our RX and TX wires. So we've got ground, power. This will be TX to RX. And when you connect this, you'll hold down this white button while we connect it. I'll put in bootloading mode. There we go. Over to the configurator. Let's go over to the ExpressLRS configurator. Click on Backpack. Pick the latest version for firmware. I'm going to do TX for device category and device. I'm going to hit HappyModel TX Backpack. Make sure you fill in all your information. Come down here, drag down your UART for your FTDI, and hit Build and Flash. Now we're writing the transmitter side of the VTX Backpack firmware to that little module. That's it. Now, if you're going to put the receiving end of it inside of your goggle module, you're going to do the same sort of thing, except for you're going to go to VRX, and then you're going to pick whatever module you're using. They're all the same. They don't make a difference. There's just different names. But if you're going to do the TBS Fusion, there's a lot of other stuff you have to do. Like you're going to have to go to Get Branch, Master, VRX, TBS Fusion, VRX Backpack. You're going to have to hook up an FTDI to your Fusion module. There's a whole process. Make sure you go to the Discord and start asking questions there. You're going to want to ask. Okay, so we can take this off of here. We can take our FTDI off, and we can desolder all our connections. All right, get yourself 4 pieces of wire, about the same length that you used for the regulator. Cut, strip, tin. And we're going to solder up our TX backpack, just like we did before. Power, TX, and RX. And here on the module, we're going to go ground, power, and this is RX and TX. We're going to want all the wires to come out of the top of the board here. And you'll see why once we get into the radio for basically decent cable management, we're going to want them coming out of the top of the board. Ground, power, and this next one is RX. We're going to want to find our TX wire, which is going to be yellow wire. So TX to RX, RX to TX, as always. And there we go. So we're left with this octopus looking thing. We have our LoRa module, we have our ESP32, we have our backpack, and we have our voltage regulator. We're going to need a small length of wire coming out of here to scab into the back of our module bay. Again, about the same amount of wire as the other 2 things, just clip, strip, and tin. Ground, power, S-port. Alrighty. I'll trim some of the legs off here. Alright, there you go. That's all the soldering we need to do to our module. Now, you can either use heat shrink or some Kapton tape to wrap up the voltage regulator and the backpack. I'm just going to use Kapton tape because it's thinner and cheaper, and I have it sitting right next to me. You're not going to want to use a lot of this, just a little bit. Remember, we're fighting a lack of space, so the thinner you can make it, the lower profile, the better. Just be careful when you're putting it on your backpack that you're not putting on so tight that you're compressing that button. And grab your craptastic ExpressLRS antenna from your HappyModel kit. And we're gonna go put that on there. We're gonna run it up yon this way. I like to kind of pin the antenna between the capacitor and the can. It's just a nice little place for it to sit. And we're gonna tape that all up. I'm gonna have all my wires exiting out the top. Like that. I'm gonna tape everything together. And there you have it. There's our nice, neat little ExpressLRS Go in Anything package. Now, it need to go in something, don't it? Let's get the radio over here. We'll start taking her apart. All right, get your radio. I'm gonna pull the batteries out of it. I'm gonna show you how to do this for the Xlite. I'm not gonna go into a ton of detail on how to get this thing apart. I'm doing this for the Xlite. This is, you know, you can do this with just about any radio. You just have to figure out how to take apart your particular radio. So take the batteries out, take the screws out of it, and then these old props work great as spudgers. You're just going to want to get in there, work around the perimeter of the radio, hoping to not, take that SD card out, hoping to not break any of the clips. Because they are pretty darn easy to break. And there we go. Should just pull right off now. All right, now that we got the radio open, we need to take off this. This is your internal ISRM, your access transmitter module. We're gonna pull off this UFL connection. This is to the internal antenna. Obviously, this is the external. Just pull these two Phillips heads here off the bottom. And it might make your life a little bit easier to take the board off the carrier. I don't know. Maybe, maybe not. Kind of slides out. And we can take this off back here too. Try to free up a little space. And there is our sweet spot. This is where we're gonna go. It's probably not the best place, but there is really no other space in this radio to put this stupid thing. I'm gonna disconnect this guy here. That's kind of annoying. I'll get that out of there. All right, we're gonna take our squid mess transmitter dealio here. We are gonna plop this thing right in there. That's where she's gonna live. We're gonna take our regulator, we're gonna put it off to one side. We're gonna take our backpack, we're gonna move it off to the other. So we're gonna kind of split the radio with the two. Our power ground and S port wire, we're just gonna kind of twist those bad boys up and route them out the bottom of the radio. This antenna, I am just going to go and stuff it down inside of here, just in front of the switches. Try to keep it as straight as you can. There's plenty of like gap up in here, so I kind of push it in there. I'm gonna put the other end kind of in front of the RTC battery here, but while trying to keep the antenna like fairly straight-ish. There we go. That seems like a good spot for her. Stick this guy in there. We're not gonna use any double-sided tape or anything like that. There's gonna be plenty of mechanical retention just because of where it's residing. I'm gonna run this set of wires and this set of wires down through here. You can twist them up if you feel like it, or if you have the room. Kind of depends on how long you cut them. Same thing with these over here. And the rest of that antenna wire, we're going to try to get it underneath this port here. No, it's not in the way of the internal board. That there ought to do it. We'll manage the rest of that stuff as we go. All right, now I put this in there. There we go. That's better. Hook up our antenna. All right, so we got our radio pretty much back together. It's kind of the way it was before. So we're just gonna take our regulator and we're gonna kind of just gonna bury that sucker away so nobody ever sees it. Just gonna stick it in there, and then our backpack, just like the other, just kind of stuff them in there so that nobody ever sees them. There we go. Just check, make sure we don't have any wires interfering with the gimbals. And we good. All right, now we need to hook up our power, ground, and S port. We're gonna take those 3 wires that we saved from earlier. Flip, strip, and tin. I hear you guys in the comments crying, don't solder over your electronics. Look, man, if you're this far in, you know what you're getting into. All right, so down here, these are the connections we're gonna need to get to. We're gonna need this one all the way on the left here. This is gonna be our power. The 3rd one in is our S port. And 7th one in is going to be ground. So we're going to do that now. And now we can put our soldering iron away. Just gonna tidy these wires up a little bit. Yeah, all right. That's it, we're done. Put the radio back together. Like I said in the beginning, or if I didn't, this is not my radio. It has seen better days. It's a little on the rough side. Some broken clips in it. But it was good for doing this little project to start with. Get your batteries back in. Go ahead and throw Edge TX on there. Make sure you throw your ExpressLRS Lua script in there.
Welcome to Edge TX. Switch warning.
All right. Now, in the model menu, make sure internal RF is turned off, external RF is turned on to CRSF. I'm gonna go into our Lua, and boom, there we go. Everything is working hunky-dory. We have all our Wi-Fi connectivity. We have the option to enable Wi-Fi on the transmitter, the Wi-Fi on the receiver, the backpack Wi-Fi, and the VRX Wi-Fi once we do have the VRX receiver module installed. Now, if this menu is a little on the slow side, or if you can't get a telemetry packet rate of 500, you're gonna want to go over to the hardware menu, and we're gonna wanna make sure ADC filter is off, and you're gonna wanna bump your baud rate up to 400,000. If you have it on the standard 115,200 what happens is when you go to your Lua, the most you can get is 250 hertz. It's just not set. And then we get up to 500. This quad here already has my bind phrase on it, and I flashed my bind phrase to the modules on this. Connector up. Boom. We have a signal. She is ready to rock. We're good to go. Yeah, shut up. All right, folks, that's it. I hope I didn't scare you off on this project. It's actually very easy to do. It's a little time consuming. I'll make sure I write out all the instructions better than probably what I said, at least the breakdown of how the board pins out and all that stuff and where it's supposed to go in relationship to all the different pieces, both the voltage regulator, the connection to the internal module of the radio, and also for that transmitter backpack function, that transmitter backpack part. I know this is not probably the best way to do this. There are some gotchas. This works. I've put a tracer module on the back of this thing and it still works. I've put a multi-protocol module on it. It still works. I don't know what will happen if I put another ExpressLRS module on the back of it. I think if you did that, you're going to want to have a different binding phrase for your external module versus your internal module. So keep that in mind. The capability of the FET for the module bay, I don't know how much power it can provide. Be smart, guys. If you're going to run an external module on this, turn your internal one all the way down. There is probably a much better way to do this if you wanted to get into Edge TX and start messing with the code in there. There are a ton of UARTs inside of this radio. Perhaps it could be assigned to a different internal UART. I don't know. I'm not going to try doing that. I would love to do it. I don't have the time nor really the expertise. The way I did this is like universal. Anything with a module bay and OpenTX, Edge TX can do this. Let me know what you think. Comments down below. Let me know what you think. Is this stupid? Do you want to do this? Honestly, I am actually very excited about this. I've put probably 3 or 4 hours in flying this setup and I've had no issues with it so far. Will there be issues in the future? I don't know. Will it overheat? I don't know. It's all a possibility, I guess. But it's a fun little project. You want to pick yourself up one of these boards, go to tweetfv.com. It'll be in the ExpressLRS section. You can pick up one of these. I have a few extra E28 modules and things like that. Probably not going to sell those. I'll put links to all that stuff in the video description if you want to buy all the pieces and parts to build this project. Obviously, you're going to have to support your own tools and things like that. But I'll put links in the video description. Well, what do you think? I had a ton of fun with this project. Lawrence, super big shout out. Thank you for sending me your radio. This dude sent me his radio from somewhere not in America or Canada or Mexico so I could do this project. I know he probably paid a fortune in shipping to get this thing to me. And I am grateful that you did that. I wanted to do this project one way or the other. If I wasn't going to do it to your radio, I was going to end up buying one and doing it. But kill two birds with one stone, make you happy, get me what I needed. Had a lot of fun doing it. First time designing a PCB using EasyADA. I had them fabricated by JLB PCB, whatever that company is. Super fast turnaround. Chinese New Year kind of got in the way. Otherwise, this would have been done like 2 weeks ago. Chinese New Year aside, production, shipping, very quick, very affordable. It was only a couple bucks for like 20 PCBs. The EasyADA program was frustrating, but I'm just trying to teach myself how to do it. I probably could do better if I was going to make this again, but it's there. You guys feel free to tinker with it as you like. I may make some changes to the design just a little bit to make it a little bit easier. Maybe with that. Nah, I'm not gonna make any changes to it. It is what it is. It works. It works the way it is. You just got to hook it all up right. All right, folks. Thanks for stopping by. Thanks for checking this out. Please stay positive and, dude, make sure you do ExpressLRS in all the things. We'll see you next time. Bye.